So what we're going to do here is we're going to look at some tables in the book that do the cumulative area of a standard normal curve. And so we're going to create a z-score, and we're going to look at the area that goes up to the z-score. So what I'm going to do is I'm going to pop over here to this table. And so notice if 0 is the mean on our standard normal table, then negative z-scores are everything up to 50%, or the 0, right? So, and if you look at this table, what you get here is you get the z value, you get the ones place and the tenths place, and then here you get the hundredths place. And so we start at that negative 3.409. Anything less than that's close enough to 0. So negative 3.49 is 0.0002 for the area under the curve. And we work all our way back up to 0.00, which is the 50% mark. And that will tell us how much area is cumulative up to the z-score we're looking at. And that's one table that does the negative scores. For the positive scores, we start at 0, which again is 50%, and we work our way up to the 3.49. See how that 3.49 brings us down this column? And that's 0.9998. Anything bigger than that's close enough for 1 for us. And here it is the area of everything up to the z-score. And so we call these cumulative areas. And so what we can do, if I switch over here, we're going to do some switching back and forth. We'll see how good I do with my switching here. Is I can, if I have calculated my z-score already, and so I say, I want to know, I have a z-score of 1.15. And so what would be really nice to know would be, what would be the area up to a z of 1.15? Z equals 1.15. So I need to know what the area under the curve is up to 1.15. So, come over here into my table, and I will want to take the positive table, because 1.15 is a positive z. And so I come down to 1.1, and I look for the 5 column. So 1.1 is gray. So I come down here to the gray, and that's the number I want right there, this 0.8749. 0.8749. So we can say the probability of a z equals 1.15 is 0.8749. Because the probability is equal to the area under the curve. We know the cumulative area on the curve up to one endpoint. So that's everything up to that endpoint. All right, let's look at another one. And let's say we want the area to the z-score of negative 0.24. So we know it's to the left of my mean because it's negative. And it has a value of 0.24. So actually it's probably closer to here on the shape of things, right? Because 1's the inflection point and 1's about there. So we'll cross this one out and we'll say it's closer to there if we're going to graph it correctly. And so what we're really saying is, what is the probability, or what is the percent area of everything up to and including negative 0.24? So I'm going to jump over to my tables. Sorry to hear me hit my mouse as I move. And I want my negative table. And so I'm going to go to negative 0.2, because it's negative 0.2, so it's this white row here, and then in 4. So I come down from 4, and I get, looks like here I have 0.4052. 0.4052 because I have a negative 0.24. So 0.4052. 0.4052. 0.4052. And so the area of everything up to there is 0.4052, or it's 40% of my stuff, right? Well, since these words, these areas represent or measure for us probabilities or percentages. Well, what this lets us do is this can let us find the area at different points. Now notice all of our areas talked about being to the left, right? Everything up to. So what happens when we want to talk about to the right, or everything after? And so if I have a z-score, draw my normal, and I have a z of 1.23, but I want to find everything after. And we're going to draw back in. Well, I know if I use the chart, I get, right, the chart will be everything up to, cumulative. Cumulative, right? Up to and including. Well, if the entire area is equal to 1, if I had everything, I would have 1, and this chunk is up to here, the other chunk after here would be the complement of that. And so if I want the right-hand side, if I want the probability, the cumulative probability, and let's write this now, get our notation, the probability of all the stuff greater than 1.23, right? And maybe we should have been saying up here less than or equal to. It takes us up to the line. But what we'll say is we'll take 1 minus the probability of everything less than 1.23. All right, like we did with the complements in the probability space, everything adds up to 1. If I know the one part, the other part is 1 minus. Well, what does this mean for us? Well, I do 1 minus, and then I come back to my table. Let me see if I can switch over to my table here. And I'm going to pull up the table for 1.23. So I go to 1.2, which is this white line here, and over to 3. 0.8907. 0.8907. So that probability in there is 0.8907, or 1 minus 8.907. What is that? 3, 9. Well, give me a calculator here. 1.8907 is 901. Right? 0.1903. Let's add them back up. 7 is 0, carry my 1, 0, carry my 1, 0, carry my 1, 0, 1. Yeah, that adds back up to 1. Sorry for quick mental math there. You've got your calculators. Right? And so the probability in this space is 0.093, or 10% of the stuff is there. All right, well, this leaves us with one other thing we can do. We can find the probability in between two things. Remember how I set this up, saying that the area under the curve relates to the probability within it? So if I have a z-score of 1.46 and a z-score of negative 0.80, and I want to find the area in between them. Well, if I know all the area up to here, and I know the area here, right, so if I know everything up to here, right, that's everything up to here, and I know the area here, if I take all of this and I subtract that pink bit out, I get the stuff in the middle. And so the probability, I'm going to call this Z1 for the lower one and Z2 for the higher one. The probability of my value, right, being in between the lower and the upper is equal to the probability of the upper minus the probability of the lower. Right, I get the area up to here, and I subtract out this bit, and I'm left with that. I have all of that, subtract that, and that's what's left behind. And so in this case, what I'm looking for is the probability of Z equals 1.46 minus the probability that Z is equal to negative 0.80. And so again, we're using tables for right now. We'll do some calculator tricks in a bit, but for right now, we're going to use the tables. And so my first table is positive of 1.46. So I come here, I come to 1.4 and over to 6, which is here, okay? 0.9279. 0.9279. So let's write that down really quick. Right. 0.9279 minus, and I come back over and I need to go to my negative table now. Now these aren't always positive and negative. Sometimes the cumulative area we're looking for is all within the negative side. Sometimes it's all within the positive. The key is it is the probability of the upper minus the probability of the lower, or the max minus the min. And so let's see here. What was that other number? It was the Z of 0.8. So we need to find 0.8. So there's negative 0.8 and zeros all the way over here. So it's 0.2119. 0.2119. 0.2119. 0.2119. And so we subtract that. 9 from 9 is 0. 1 from 7 is 6. 1 from 2 is 1. And so the area in between these is 0.7160. And that's how we find the area in between two Z values. And so remember that our Z score maps from whatever we measured to the standard normal. The standard normal we know the values for. And so we can we can find the percentages or the probabilities up to or around those particular numbers. All right, that's using the tables. I'm going to record another one of these with some different numbers using the TI-84. If you have the TI-30s or other calculators, you don't always have the feature to look up the probabilities from the Z value, but you do have those tables, and those tables are in the front of the fold out of the book.